Thank you, Serafino. Thank you, Michael. My name is Chu Hanlin, and I'm the exoskeleton team. But before I go further into my presentation, I would like to talk about the word exoskeleton. The reason we picked the word exoskeleton for this shot outside of this quadcopter is because we want to give you an idea of the exoskeleton of an insect, of an anthropod, like a lobster. What happened is that those exoskeletons, the purpose of those is to protect the soft interior of those animals. In this case, it's just doing the same thing. It's protecting the fragile electronics and the rollerblade of the quadcopter inside of it. Now, putting a shell around the quadcopter is not a novelty. It has been done before many times. As you can see, UDI quadcopter is one of the most common designs. Basically, just a solid rim around the rollerblade. It protects the rollerblade from collision, so it can continue its function. And there is also the spherical flying machine that's developed recently. In fact, this design is what I draw lots of inspiration from. The spherical flying machine is a solid shell outside a single rotor craft. What it does is it allows the rotor craft to fly into almost anything, floors, walls, ceilings, and bounce off and continue flying. It's the basic purpose of it, obviously, is protection of the rotor and the whole craft itself. There's also the Illipole flying pole. It's actually Illipole flying pole. It's actually in the market. You can buy it, search online, and you can see the design is mostly raw. And the reason for that is because it's more lightweight, because quadcopter has a really limited amount of payload, and also because of the airflow. Now, airflow is really important in quadcopter flight because of the lift it generates all about airflow going through the rollerblade and down. So if you have too much surface below the quadcopter, what happens is that it will create drag, and that will cancel out the lift, and it doesn't fly anywhere at all. And the last one I want to mention is the high-tech robot. It is a really interesting design. What happened is that the shell outside of it is actually rotatable using the shaft device there. So basically, it allows the quadcopter to hover low on any surface, and the shell is rotated. And as you can see, the last picture is one of our first design. It's actually a failure because of the too much surface we have underneath. And after that design, we switched it to a raw design right now, and it actually flies. And you'll see it shortly. So, one of the main things I want to talk about is, why are we putting a shell around the quadcopter? What is the purpose? Well, as mentioned before, there's a roller protection to protect the object, the quadcopter itself, and there's also the ground roller motion. What it allows is that it allows the quadcopter has more mobility, more versatile, can travel more versatile terrain. But what we want to emphasize most, though, is air droppability. Imagine you just toss the quadcopter outside the aircraft. It's just going to flip crazily and crash the ground. It's not going to go anywhere. So one of the reasons we try to attach a sphere around it is that so that when you, well, it's kind of bare right now, it's just a skeleton, but say we put some net, some surface, some mesh around the exoskeleton, what we can do is that when we toss this thing out of the aircraft, it might be able to just generate enough drag for the quadcopter to react and start turning the blade, and it'll generate enough lift to fly off. And that is, in fact, one of the main goals of our research, now that we have a functional exoskeleton shell around it. Now, depending on the mission, it might be able to attach various appendages onto the quadcopter exoskeleton because it creates more surface for attachment. If you see closely at the quadcopter itself, it's already full of electronics and other wirings. It's really hard to attach anything else onto it. So, having a shell outside, we can attach more things on it. And just imagine there's a surface around it, there might be chances for sound destruction. As we fly the quadcopter around, you'll hear there's lots of noise generating around it. So if we don't know what is possible or not, it might be able to become stealth, a little bit stealthy. It's flying high up in the air, the stealth reconnaissance aircraft. Now, having introduced all three teams, we'd like to create a demonstration that's going to involve all three different teams project together. And we're going to show you how they can function together to complete the mission. So, as you mentioned, as you hear before in different presentation, there are certain mentioning of neutralizing a criminal target, or airdropping a first aid kit, or even surveillance around an area. What we're going to do now is we're going to give you a scenario. Pretend, as you see in the video, that the ground robot is able to locate, is able to traverse throughout the difficult terrain, and that the whole mission purpose is to locate a certain, say, bomb or unexploded ordnance, or even a criminal. Now, the reason for that we want to send a robot instead of a human SWAT team or something like that is because we want to save life. There might be unknown bombs around, there might be dangers around. So instead of sending a human element in, we send in a robot first. For if we have more information on the topic, we can operate more safely and therefore save lives. So what we can do first is that we can send in the quadcopter with a shell. And what it can do is that it has a protective shell zone. So say if it travels to an area that's too close to a designated device such as a bomb, it has something that can protect it. So to avoid complete damage or destruction of the robot itself. So what we're going to do right now is we're going to fly that quadcopter around the room, and then we're going to land it. We'll just drop it somewhere around the stair. And if the shell is rigid enough, what it's supposed to do is supposed to carry the quadcopter safely down. It'll just roll down here, bounce off, and land it right here, and the quadcopter will be safe. Now, before we actually throw the quadcopter down the stairs, and I roll down, I want you guys to keep hands and feet inside the chair, because it will bounce crazily down the stairs. So somewhere around the stair area, please be careful. All right. Now, as you take flight, you'll hear your voice. I can fly over you, so you'll also have airflow pushing down on you. As you're doing this today. Pretending the scout has returned and we want to have very more detailed surveillance of the area, or as if there's an operation going on, we want to make sure that no threats enter the perimeter. We can send a quadcopter with a camera on, or even to deliver a first aid kit in case there's an immediate medical requirement that's going on, or there's injury casualties that we need to pay attention to. So what's going on now is Michael is going to fly the quadcopter, and he's going to fly with a first aid kit attached to it, and he's going to drop it to Sarfina over there. Now we're going to turn the camera on and to see the live stream of the camera to the screen out there. Now see, the camera is actually attached to an iMovie, so currently you can actually see the image transmitted to the screen. you turn the lights on, and immediately become a color video. So the quad rotor is not only suitable for daylight mission, but also accomplishes pretty well in vision at nighttime. So that about concludes our demonstration. And as you can see, most of the stuff is still pretty basics, pretty early on, but there's lots of potential we can do, the combination of the ground robot with the aerial robot team. So thank you. And now we'd like to thank a couple of staff and faculty in the Prescott area that helped us.
We'd like to thank Dr. Curtis James, the Director of Undergraduate Research here at Embry Riddle. Without him, this day and Ignite Discovery Day would never have happened. We'd also like to thank Dr. Ron Mather, Dean of College of Engineering, for giving us a room to work in the AXPAT building. We'd also like to thank the Cottonwood Police Department and Verde Valley SWAT team for coming here today and for giving us the robot. Special thanks to Chris Smith and Patrick David, the machinists here on campus, who gave us inspiration and their ideas of how to build different things such as the wagon and the exoskeleton as well. Although he didn't want to be his name put on the slide, we want to thank our advisor, Dr. Joe Yule, who has shared his interest and passion in robotics with us and has spent countless hours with us in meetings and everything like that. Dr. Yule. This concludes our presentation. Feel free to come up and ask any questions if you have any. Thank you. I'm Michael Brown, and I'm a junior currently, right now, about to be a senior next year.
Daniel Nicholas, like Michael, I'm a junior right now, I'll be a senior next year.
I'm Michael Rosnick, I'm a freshman here.
I'm Chun-Hong Lin, and I'm a sophomore, going to junior.
Yeah, we had a couple of technical difficulties, that's why I didn't show it in the presentation, but we'll fix it real quick and show you guys.
Well, you guys feel free to come on here and look closely at the quadcopter. If you want more demonstration, you can fly it around more. If you have more questions, you can ask us.